Hi guys, today I'm going to explain continuity at a point. So you can see this graph, this simple graph where we have two functions labeled A and B. Now, the definition of continuity is that if the graph of the function doesn't have any breaks or holes,
That's easier down. One here down. That's that. Oh, easy. Ini kayak gitu lah. Bos. Ini yang bisa nih, there's no.
then it is a continuous. So as you can see here, the function A is continuous since it has no breaks, while for your function B, it has a break or a hole here. See, as you can see, if it's shaded, then it's not a hole, but since it's not, therefore it's a hole. Therefore we can say that function B is not continuous. Now, I was given these two problems, two piecewise functions in fact. F of x is equal to x plus 7 when x is less than 2, 9 when x is equal to 2, and 3x plus 3 when x is greater than 2. How do we know if this piecewise function is continuous? Firstly, there are conditions to know if it is continuous. First of all, if f of c exists. Second, if the limit as x approaches to c exists. And lastly, if f of c is equal, remember that, to the limit as x approaches to c. Okay, so first of all, f of c must be exist. As you can see here, we're going to see if point 2 is continuous. So let's go. Since x is equal to 2, therefore we can say that f of c exists. That's check. Next, the limit as x approaches to c must be exist. Remember that in order to have a limit to exist, the left side and the right hand side of the limit must be equal. So let's check this and this. X plus 7 as x is less than 2, and 3x plus 3 as x is greater than 2. Okay, we're going to find the limit. So we're just going to substitute. X is equal to 2, so 7 plus 2 is 9. 3x plus 3 as x is greater than 2, so 3 times 2 is 6 plus 3 is 9. Since both of them are the same, therefore the limit as x approaches to c is 9. Now, since f of c is equal to 9 and the limit as x approaches to c is 9, therefore all three are satisfied. So we can say that this piecewise function is continuous at point 2. Now then, we're going to see if this piecewise function is continuous at point 3. So we can see in this problem, x is less than 3, it seems that I put addition sign. It must be equal. This is equal. That's why I was confused. Okay. At x is equal to 3, then x minus 1, and x is greater than 3, which is 30. So, f of c exists. Since x is equal to 3, we're just going to substitute this, which is 29. Okay, f of c is equal to 29. Now then, the limit, the left hand side and the right hand side, we're going to check this. So let's just substitute 4 multiplied by 3 raised to 2 minus 2 multiplied by 3. So 3 raised to 2 is 9, multiplied by 4 is 36. 36 minus 6 is 30. Okay. Now then, 30 as x is greater than 3, we're going to check that. Since it's 30, then it's 30. So since the limit, both left hand side and right hand side are equal, therefore the limit as x approaches to c exists. However, Remember the third statement? Both f of c and limit as x approaches to c must be equal. Since this is 29 and since this is 30, they are not equal. So therefore, at point 3, it is not continuous. So that means this piecewise function is continuous and this piecewise function is not continuous.